average product of labor, right? So I know marginal product of labor goes through here. That's true, right? So it goes from being positive to negative right here. I know they cut. So what happens to the left of this point? Right? I'm going to draw it for you, and then I'm going to explain to you the intuition why that is. It looks something like this. At this point here, marginal product of labor is increasing until it gets to the inflection point on the total product curve, then starts dropping, hits the maximum of the average product curve, and then keeps on dropping until it goes negative at the point where the total product curve has its flat spot. Right? To the left of the point where they two intersect, marginal product of labor is above the average product of labor. What's happening to average product of labor to the left of this point? It's rising, right? This is your sophomore year after a really terrible freshman year, right? You're doing much, much better in all of your classes in your sophomore year than your freshman year, and you're pulling up your GPA. Your grades are better than your GPA is going up. Here, to the right, what's happening is your grades are worse. You're taking upper-level econ classes, right? And this is your GPA. As you're taking the upper-level econ classes, your grades are worse than your GPA, and your GPA is going down, all right? This is the what just happened moment. There's two types of people in this room usually. The one type says, I can do this in my sleep. This is really easy. Answer is 1 out of 10 chance that that's actually true, all right? So practice. The second group is, this class just got abstract in the way that I've always knew economics was, right? So that's also true. So what we're going to do for a second is we're going to draw this one more time, slowly but abstractly, without numbers, all right? Because we're going to use these curves over and over again in order to, oh, excellent. In order to figure out what the firm does, okay? So let's draw the total product curve, then let's figure out the points on the total product curve that matter, and then let's draw the marginal and average product curve in the bottom graph, okay? So the way to start is to simply draw a U, like this, and then an inverse U on top. Right? That's what a total product curve looks like. So 3 points matter. The first point that matters, and I'm going to erase that line in a second, is the point where the line from the origin is exactly tangent to the total product curve. This is here at 7 units of labor, but however you drew your total product curve doesn't really matter. So at 7 units of labor, that's the point where average product goes from being positive to being negative. Okay, let me do this again. Okay, so that point was somewhere here. Right, at that point, average product goes from being positive to from going increasing to going decreasing. The marginal product goes from being increasing to decreasing where? By the way, it's totally fine to say wrong answers. I don't grade you on what you say in class. I grade you on what you write down, right? So take your shoelace. It's increasing until we get to the inflection point, right? After the inflection point, it's the slope of the line increases, and thereafter it decreases. So at the inflection point, which you can always spot because it's sort of hard to draw it and we never get it perfectly smooth, it's where you have that little squiggle in your line right there, right? That's where marginal product of labor goes from being increasing to decreasing. So the last point that matters is, of course, the top point of the curve. That's where marginal product goes negative. So let's draw, and the easiest way to get that is to just draw lines straight down to this bottom graph right here. Okay, here's one line. Here's the second line. They're a little bit close together, which isn't great, but and here's the third line. So always start with average product first. The average product, so the middle line right here, this one, is the one where the line from the origin is exactly tangent. This point here is the line where the line from the origin is tangent to the total product curve. So the middle one is where average product goes from being increasing to decreasing. So this is average product of labor. The second point that matters is this one right here. That's where marginal product of labor goes from being increasing to decreasing. Then it cuts through this point right here and goes negative at this point right here. So the way I do it, it works well psychologically for me, is just put dots at these points, okay? Pick a point up here where you're not going to drive yourself crazy, okay? So it goes up, down, and negative right here. Beautiful, isn't it? Draw that 15, 20 times at home. We will never draw this one, right? Because it's boring. All the firm's behavior is captured in this one. Okay, of course, these two curves here come from the top one, but the average and marginal product curve will drive what ultimately will be your marginal cost and your average cost curves. Marginal cost curve will drive how much output the firm produces, and the average cost curve will, or a version of the average cost curve will tell us whether a firm should produce any output at all or not, right? So these two curves here are crucially important. Learn how to draw them, practice, 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 or you will tank the second midterm if that's not motivation enough. Okay, just to check our understanding here. What about a linear total product curve? Like a, tutoring lesson production curve. 1 unit of max required for 1 hour is 1 hour of economics tutoring. So each additional unit of labor produces the same amount of additional tutoring. That's a linear total product curve. It looks something like this. These are really small graphs. Here you go. This is my total product curve. TP is probably a bad acronym. Total product curve, or short run production function, whichever way you want to call it. So what's the average product of labor of such a total product curve? What's the slope of the line from the origin to any point on this total product curve? Does it change at all? It's the same, right? Each additional unit here, in the way I've drawn it, produces 10 more units of output, right? So because the line is a straight line, any line from the origin connecting to any line on that total product curve is going to be the same number. In our case, in the way I've drawn it here, 10. So this is my average product of labor curve. What about my marginal product of labor curve? How many more tutoring hours, or whatever this product is here, do I get out of 1 more unit of labor? always 10, right? So if you look at the slope of this curve at any point, this is terrible. I need stairs. I'm bringing a ladder next time. But if you connect any of these 2 points here, right, the slope of connecting any 2 points on the straight line have the same slope. That means the marginal product of labor is the same. It's 10 here, right? For each unit of labor, I get 10 more units of output. What was the average product of labor? 10 and constant. So for the linear total product curve, the average product of labor is exactly equal to the marginal product of labor everywhere. If I can produce 10 units of something per hour for infinity, I, on average, no matter how much I produce, will always produce 10 units per hour. And if you hire me for 1 more hour, I'll always deliver 10 more units, right? So the marginal product of labor and average product of labor for this very special case total product curve here is the same. Okay. Now, something really important, laws are important, right, is this law of diminishing marginal product. We had a law of diminishing marginal utility that said eventually the marginal utility from consuming 1 more unit holding the consumption of other goods has to come down, right? It's this notion that the second glass of water after a run still makes you happier, but it gives you less additional satisfaction than the first one, so goes the third one, fourth one, fifth one. With marginal product, there's a similar rule here, or law. If you increase one input and very, very importantly, hold everything else constant, right, capital, information, technology, corresponding increases in output will become smaller eventually, right? Or, in other words, the marginal product of labor will get smaller eventually, right? Are there portions of our total product curve where the marginal product of labor was actually increasing? Yeah, there was, right? So let's look at our picture. If we go back to this picture right here, not that one right here, right? Marginal product is increasing in the beginning. Does that violate the law of diminishing marginal product of labor? No, right? It says eventually at the end. So as you add more labor, even though marginal product is increasing here, at some point you're going to add labor, and the marginal product of labor is going to start diminishing, right? Hold capital and everything else constant, the marginal product of labor eventually diminishes. It doesn't say it's always diminishing. Now, one of the counterintuitive things I'm going to show you, even though like this seems to be the place where you'd want to produce, right? Yeah, increasing marginal product is awesome. Firms will never, ever produce in this part of the marginal product curve, right? They will always produce somewhere over here, which we'll get to, but just to show you how useful it is what I'm explaining to you on a day-to-day basis, okay? Now, we're going to talk about something called diminishing marginal returns. I do this every year. Let's create some new language here. Scrap the word returns and put product here. They're the same thing, but people get horribly confused, okay? So do not confuse diminishing marginal product and diminishing product, right? One talks about the level of production, diminishing total product, versus the other one talks about the change in product. This is like talking about the level of a function versus its first derivative. The two are really different, right? This is how high off the ground we are in the total product curve. This here is what's the slope of the total product curve. So be very, very careful. There is no law of diminishing product, right? But there is a law of diminishing marginal product. You add more labor holding capital constant, eventually the marginal product will fall. Now, you've read more Malthus than I have or ever will, right? Was it fun? Yeah, it was. Come on, you go back, your primary sources, Alan Karras, really important. So this is always where we do some pathetic attempt to engage in some pathetic attempt to seem relevant here. But, where was Malthus wrong for now? Go. You're wrong one. There we go. Productivity. Close, all right? I won't tell Alan you said that. All right, excellent. Yeah, no, so the health technology constant, right, or productivity constant. What's happened to agricultural productivity over the past 500 years? It has exploded. I mean, if you look at the productivity yields, for example, is one measure of productivity of rice, corn, sorghum, soybeans, anything out there, they've exploded. So we're able, through agricultural production technology, to maintain a much, much larger population than Malthus anticipated, right? Will Malthus ultimately be wrong? That's not clear, right? So in a world of 10, 11 billion people, how much water, how efficiently are we going to use water to produce food to get people the calorie and macronutrients they need, right? So it's a debate that to me isn't over, but we could talk about that at some other point when we're not so pressed for long-run production. Okay, let's just quickly sort of wade into long-run production. So in the short run, capital was fixed, right? That was pretty neat. I can see that. Fancy Italian espresso machines take a while to get installed. But let's take a longer view, right? How big should the Starbucks on Oxford and Center be, right? Most of these stores come in different sizes. Like Targets come in different sizes. Walmart's come in different sizes. Starbucks come in different sizes. What size store is the right one there? Is it a 2, 3, 4 espresso machine store or a 1 espresso machine store? So in the long run, all inputs are variable, and you can freely choose how many units of labor and how many units of capital you're going to use, right? So in the long run, you get to choose both K and L, and you can substitute between the two, right? You're planning for the next year or two, not for tomorrow. Now, much like in utility theory, where many different bundles can give you the same level of happiness or same level of utility, right? That's where an indifference curve comes from. You can produce the same output with different combinations of capital and labor. For example, if you think about cash dispensing, right? Most of us get our money out of ATM or Mac machines, depending on where you're from. That's a very, very capital-intensive way to dispense cash. Could we do the same thing with more labor? Talk to your grandma, right? There's actually a door next to the ATM machine. You can walk through it. There's people inside that with an ID and your card will hand you cash from your account, right? Much more labor-intensive. So just looking forward a little bit, why have we rolled out ATM machines like crazy instead of having human tellers that greet you and say nice things to you? Much cheaper to use ATMs, right, than actual banks. Also, there's a technological advantage that these teller machines are open 24 hours a day versus humans work 8 hours a day or 10 or 12 and then the bank is closed at night. So the notion here is we can choose between very labor-intensive, very capital-intensive, and which combination we choose is ultimately, as we'll see, going to depend on prices, but we're not quite there yet. But what we have, again, is we have this production function. Our production function is the same one we've had before, right? F didn't change. You're combining labor and capital, and you're producing output. This is now a capital Q for some reason. It should be little q. But you now get to choose K and L. Before, K was fixed, and you only got to choose L. So if you choose both, it's like Aladdin said, a whole new world, right? So what you've got is you've got some really... my kid loves that song, and he gets the lyrics wonderfully wrong. Maybe I'll play you a recording one day. It's amazing. So combine capital and labor. Right now you get to combine capital. So I've got here from 1 to 6 units of capital. and labor, 1 to 6 units of labor. And what you've got in the middle here is if you combine any of these units of capital with labor, how much output you're going to get. So if you're combining 3 units of capital and 2 units of labor, right, go across here until you get to 2, you're producing 24 units of output. Now what I did is with my artistic talent here, I have said, well, can I only produce 24 units of output with this combination of capital and labor? Turns out for this production function, I can also produce 24 units of output with 1 unit of labor and 6 units of capital, 2 units of capital and 3 units of labor, and 6 units of labor and 1 unit of capital, right? This here is a very capital-intensive way of producing 24 units. This here is a very labor-intensive way of producing 24 units. How about 35 units? Well, if you want to produce it in a really capital-intensive way, 6-2, or in a very labor-intensive way, 2-6, right? So here, the orange ones tell you the combinations of capital and labor that produce the same amount of output. Does that seem familiar? Combinations of Hershey's and Reese's that give me the same level of utility? Yes, it's the same sort of concept, right? If we took this table, we turned it around, we plotted it in this corner, and then we built sticks in inches that were as high as these numbers, what you would get is you would get a function, right, that is my production function. And if I sliced it at 35 inches, then I would get all the combinations of labor and capital that produce 35 units of output. Now, what did we call the curves? You know what? I'm going to cut you some slack. I've crammed a lot of material into your brains today. But let me just tell you where we're going, right? These are combinations of capital and labor that produce the same amount of output, the same quantity of inputs. How do you say same in Greek? Iso. And then here you're producing quantity of output. Same quantity of output is going to be called an isoquant. So these curves right here are going to be called isoquants, and you will spend a lot of time getting to know them. I have office hours from sometime till sometime today, 3 to 4:30, 3:30 to 5 I have office hours, and from 5 to 6:30 I'm teaching a review session next door. I will see you there.